Easy Lessons in Einstein by Edwin E. Slosson. Section 6. The egocentric theory of the universe. But the framework that we construct to hold everything outside of ourselves is essentially of the following form. You are the centre of your universe. Everything and every event that you are considering is related to you, here and now. Starting from this, your point of place and time, you imagine 8 straight lines stretching out towards infinity in 8 directions, as divergent as possible. These lines, call them destinations or directions or dimensions or coordinates as you please, consist of 4 opposing pairs, right and left, up and down, forward and back, future and past. Somewhere along or between these 4-dimensional lines that cross in your brain, you could find a place for anything that you need: your pencil, the discovery of America, the sun, and next Friday. You can connect up all these things by lines which may represent changes, that is, the tracks of movements in space and time. To connect the pencil in your hand with the discovery of America, you would have to count back 428 years on the timeline and measure off on the east-west and north-south lines whatever distance you may be from San Salvador, not to consider the motion of the earth. Anything that exists, that is to say persists, is moving along the time dimension at what appears to be a uniform rate. Of course, you can, if you like, conceive of time itself as a stream flowing through things. Since all motion is relative, that way of looking at it is just as true as the other. But it is simpler and more sensible to think of things moving through a stationary time just as we think of them moving through a stationary space. A material point that is at rest, such as the dot of a letter I on the page of a book, we continue to disregard the motion of the earth, is not moving about in space, but is moving forward in time. Its track, then, is a straight line along the time dimension. That is, a material point is a line in the 4th dimension. If you move the page of the book to the right, the forward movement of the dot of the eye in the time dimension is combined with the sideways motion in a single slanting line. If you move the page simultaneously upward, rightward and backward, the track of the point is a line combining the movement in all 4 dimensions. Such a track of a point moving through space and time is called its world line. It is a continuity of one dimension. Any event is the point of intersection of one or more such world lines, and we can never observe anything except such intersections. That is to say, everything happens somewhere and sometime. A picture flashed on a cinema screen has 3 dimensions. It's 10 feet long and 6 feet high and lasts 1/16 of a second, but it has no thickness. A man necessarily has 4 dimensions. He may measure from 24 to 72 inches in one dimension, from 8 to 18 inches in the second, from 4 to 9 inches in the third, and 70 years in the fourth. Above all, the idea of the relativity of time ought to be easier to accept than that of space, for it is in accord with experience, instead of contrary to it. We drop off to sleep and wake the next instant, if we credit our personal perceptions. Why should we believe the sun and the clock in preference to ourselves? Bergson bases his whole philosophy on the distinction between duration, as it is felt by the individual while he is living through it, and time, as it is employed by the physicist in his calculations. The latter conception, physical time, is, as Bergson says, a mere invention of man, and virtually a 4th dimension of space, so he concludes. To sum up, every demand for explanation in regard to freedom comes back, without our suspecting it, to the following question: can time be adequately represented by space? To which we answer, yes, if you are dealing with time flown, no, if you speak of time flowing. Past and future are alike to the physicist, differing only in direction, like east and west. But to the living person they are altogether different things. For man rolls up his past as a tourist his rug, and carries it with him wherever he goes. That is why Wells' Time Machine and the reversed reels of the movies are so funny. There is nothing absurd about running a wheel backward, but there is about running a man backward. The physicist feels no reluctance about turning the stream of time backward, for all physical phenomena are reversible under the proper conditions. If we interpret the universe as merely matter in motion, and imagine at a certain instant that every individual particle reverses its motion and goes in just the opposite direction at the same speed, then the whole history of the world would be reenacted in the opposite order, and the earth would return to its primeval nebulae. In Wells's story, The New Accelerator, a professor invents an elixir that speeds up the rate of living 1,000-fold. A person taking a dose of it sees people as wax figures, apparently motionless in the midst of violent action. Falling objects seem to stand still in the air. The music of a band is reduced to a low-pitched wheezy rattle, or the slow muffled ticking of some monstrous clock. But in compensation for this, the accelerated drug fiend could watch at leisure the slow flapping of a bee's wings. But even Wells, with his 7-league boots imagination, finds it difficult to keep ahead of the march of science. What he then saw only with his mind's eye, we can actually observe. By moving the accelerating lever on your phonograph towards the S end of the scale, you can slow up the tune and lower its pitch until it becomes inaudible as music. The new Pathé ultra-rapid camera can take pictures at the rate of 160 to the second. When these are projected on the screen at the usual rate of 16 to the second, all movement takes place 10 times slower than in actual life. This gives opportunity for the study in detail of the action of a ball player pitching a curve, or of the wing motion of a hummingbird, or of the splash of a marble falling into water, or of the flight of a bullet. We can magnify motion or minify it as much as we will. The cinematograph owes its origin to the desire of Senator Leland Stanford to study the movement of a horse's legs, so as to find out why one racer went faster than another. Such playful flights of the scientific imagination as Wells and Flammarion indulge in, and such freaks of projection as the cameraman amuses us with, are of use to those of us who find difficulty in translating a mathematical formula into terms of everyday life. There is no better place to study metaphysics than in the world of the flickering screen, for there man has complete control of time and space. He can enlarge and reduce any object. He can hasten, retard, or reverse any action. He can throw upon the screen, at the same time, events happening months and miles apart. Therefore, to those of us who have had the advantage of an education in the movies, Einstein's ideas of the relativity of time and space do not seem startling or inconceivable. Kant not only conceived the possibility of more than 3 dimensions, but believed in the probability of it. His argument is based on greater insight into the intentions of the Almighty than we of this day would claim. If, he says, it is possible that there be developments of other dimensions in space, it is also very probable that God has somewhere produced them, for his works have all the grandeur and variety that can possibly be conceived. In this temporal, spatial, and material world of ours, reality requires that the 4 dimensions should hang together. But at an infinite distance from all matter, this 4-fold combination would be dissolved into a 3-dimensional space and a 1-dimensional time. In that extra-mundane realm, time ceases to flow, gravitation no longer drags downward, matter is non-existent, light is immovable, and change is impossible. Thus, the new mathematics leads to a state curiously like the conventional conception of heaven. We talk as our forefathers did about the ends of the earth, but we know that one might start from his home and walk forever in any direction without coming to an end of it. But although the earth's surface is infinite in the sense of endless, yet one can never get more than 8,000 miles away from home, where'er he may roam. If a man stood on the top of the highest mountain on earth and aimed a level gun in any direction, the bullet, if it could be given sufficient velocity to counteract the influence of gravity, would go round the world and hit him in the back of the head. Or, if light were sufficiently deflected by gravitation to follow a level line round the earth, another absurd assumption, the man looking through a level telescope in any direction could see how his hair was combed in the back. Such happenings, though impossible, are not inconceivable, but are logical consequences of our knowledge that the world is round, and that what we call straight or level lines as measured on plane or sea are really great circles around a centre 4,000 miles below. Now, Is it not also conceivable that the lines we call straight in astronomical space may also have an imperceptible curvature in some unknown fourth dimension? If this curve is closed like the circumferences of the earth, a ray of light pursuing a straight course in a certain direction might eventually return upon its track, even though not refracted or reflected by the matter it passes through or by. A telescope of unlimited power pointed into space at a tangent might then show the observer his own back, if light were transmitted instantaneously, but since it is not, and since the curvature of space, if there be any, is exceedingly minute, what the observer would see, assuming that the earth had come back to its former position, might be the scenes of some geological age millions of years ago. End of section 6.